second week. All right, so Mr. Abramson, yes, you're here. Mr. Kavanaugh, Mr. Kuhn, wake up. Mr. Freeman, Mr. Hidalgo, you're here. Mr. Pine, Mr. Price, Mr. Rector. What is there to deal with this early in the morning? Mr. Reed, Mr. Smith, Mr. Timberman, and Mr. Woodward. Excellent. So we're just missing late dude. And apoplectic and having kittens. All right. Well, that would that would explain it. So let's look at a couple things. So I've got Riley's project opened here, just for. But of course, these all should have basically been the same deal. So a couple things we were just talking about briefly before class is the idea of the acceleration, right? So acceleration is what makes gravity, is how we're modeling gravity. So the acceleration was set to be, on this case, 500. The number, right, is up to you, but why is it positive? Because remember, which way does the y-axis go? Well, up and down, yes, but which direction is the positive y-axis? It's down. In math class, it's up, right? In computer graphics, it's down. Annoying, right? But c'est la vie, okay? So then accordingly, when you hit the button to jump, let's see, where is that? Here it is, okay. Right there, then when you hit the A button, set sprite's velocity, in this case the character, to negative 200. So that means that the character is actually moving upwards, okay, not downwards. And then the reason that the character falls back down is because, so the MakeCode is doing this in the background so you don't have to worry about it, but it's basically every tick of the game, it's applying the acceleration to the velocity of any object. Okay, so the and actually I should mention the acceleration is not a universal property. It's defined on a per sprite basis. Okay, which is why you can have the enemies flying even though your character is subject to gravity. Okay, did you get those dishes done? Yeah. You want to come over to my place after class? I got a sink full of them. So, yeah, sink full of dishes, bunch of recycling to take out. It would be great. I could bring all of you guys over, right? You can dust, you can vacuum, you can do dishes, right? No, just 100% quid pro quo. Non-failure for dish doing, right? Yeah, okay. So so what the engine is doing is that if a sprite has an acceleration, then it's applying that acceleration to the velocity every tick or time unit, basically. So so if the velocity is right when you hit the button is 150 upwards, okay, then it's going to add basically a factor of this acceleration, and it adds more and more the longer that time has gone on since you've hit the button, which is why you slow and then you hit a peak and then you come back down, right? Until you land on one of the blocks or something else, and then the all this business, not here, but there's the stuff, where is it? On sprite of kind player, where is it? That's what happens when you touch enemies. I guess it's actually just built into the tile map so that you don't have to basically tell it what to do when when the character touches a block. Well, because this stuff right here is for sprites of kind enemy, right? So this is what the enemies do if they touch the walls. Where? This is what happens if you hit an enemy. Okay, but not a wall. Which I do want to talk about that, so we'll come back to it. That generates the enemies. Yeah, okay. So that stuff, and this is, we were talking earlier, what's so nice about this versus Scratch? The game engine is smart enough to know that, hey, a tile map, you don't want to fall through the tiles, right? And so we didn't actually have to code to stop the acceleration when you hit a tile. It just does it for you. Man, that was nice of them, right? Um, Now, when we get into Unreal Engine, there's a couple things that will control that. One is that objects can have a collision thing attached to them. Those of you guys who play FPSs and probably whine about hitboxes, right? Or not hitting the hitbox even though you thought you hit the hitbox. Yeah. So the reason for that is basically that the geometry of your enemies or whatever is super complicated, and determining whether or not you've hit them is much easier if you just have like an invisible box that's around them. Well, and then you just check, hey, has my bullet or whatever hit that invisible box? Well, that makes the math a lot easier, but it also means that, you can have a situation where, like, if my head sticks out and there's a little bit of an indent into my neck and my box goes right, then the bullet could kind of appear that it passes my neck and yet it still counts as a hit. Um, so uh, we won't have some of those luxuries when we get into Unreal Engine, but this is made for kids, right? So it's trying to be as friendly as possible. Okay, so does that kind of make sense about the velocity business? Um, and then similarly to the velocity of the player character, we've also got all this business going on with uh, the enemy. Okay, and here, uh, and actually, shouldn't these be value? Yeah, okay. So, okay, that I was a little confused about that. So, probably if we played this, it would be a little janky in terms of the animation, because what what is going to happen if, for example, if an enemy touches a wall bottom, okay, and then it's going to set the velocity uh, of the player character to 150, not its own velocity. Okay, well, that explains it, right? Okay, so right, so this illustrates though that the velocity, acceleration, position, right? It makes sense that position is something that's specific to each sprite, right? Because each sprite can be in a different spot, right? But they can also have their own velocities, and they can also have their own accelerations. Okay, so and the acceleration can have multiple components. So, for example, like let's say we were making a racing game or something like that, then the acceleration would be like like your accelerator pedal on your car. And it could be that as you steer, right, your acceleration would basically point in the direction that you were facing. Okay. The math would be a little bit more complicated because then this would all be two-dimensional stuff, but um, it's not that bad, right? It's just calculus. God, what's the problem, gentlemen? No, not so into calculus. Yeah, no, all right, whatever. Okay, so right, so you got to make sure to access the correct thing. Now, what this also means is that, like, let's say that you had an enemy and you wanted the enemy to be subject to the same gravity that the player was, you would have to set the gravity for both the player and the enemy object separately to be the same number. Um, but the advantage of having the ability to set it differently for different sprites is that you can have flying enemies that aren't subject to acceleration, or station, ones like, I mean, I'm thinking, like Mario or whatever, right? You got the bullets that fire, bullet bills, right? That don't go up or down; they just go side to side at whatever velocity. But then you've got like the little turtles, the Koopas, was it? Yeah, Koopa Troopas. I used to know all of this stuff. Like, in fact, I'm having flashbacks to when I was like 5 or 6, and my neighbor next door called me back when you did such things with landlines to ask me like what to do on the underwater world in Mario Brothers, the first one, and what was with the fish, which are called Cheep Cheeps. Yeah. So, yes. And now he's all grown up and he's a lawyer in New York City. So, with I think 2 children. Anyway. Um, so, yeah, the miracles of Facebook. I can find people again. Of course, it helped that his last name is like incomprehensible to spell. It's Spazovich. But being Polish, there's like J's and C's and Z's and stuff hidden all over the place. And yeah, if his name was like Michael Smith, that would have been a lot harder to find, right? So anyway, okay, so right, so you could, if we were to spice this up and have multiple types of enemies, um, then we could make, say, one of them be able to fly and another one be able to just walk along the tile. And then, like with the Koopa Troopas in Mario, right, there are certainly times where they got stuck and they just were walking back and forth and bumping into pipes or whatever. Um, and But they were still subject to gravity, and maybe they'd fall off or fall into a pit. Uh, okay. Now, in this case, what took the role of the pits? Yeah, the little death boxes, which, for the sake of this game, didn't have to actually be in a pit, right, to trigger. But in like the original Mario, that's certainly how they worked. Also, in the original Mario, uh, they weren't like, there wasn't any icon that visually told you that was a pit of death, right? You just sort of learned. So here we've got it, it's an actual tile, but you could imagine making it just sort of like a transparent tile, or one that didn't actually look like anything, or actually just looking at the y coordinate of the player. Okay, so if, like, let's say when you design your tile map, you never have a tile that's below, say, the second row up that the player is going to walk on, then you could say, okay, excuse me, if my y value of any object is ever less than, or actually greater than, because it goes downwards, right? Then blah, then it has gone out of the map and it should be destroyed, or deleted or whatever. Okay. Um, yeah, good. Okay, so the other thing I wanted to kind of chat briefly about was, let's see, where is it? Um, well, several things. Um, First off, you see how the game made you make a function, right? So a function is how you can encapsulate a lot of things into basically a single block. Okay, the functions actually you can give them numbers or objects to work with, and they can pass back numbers or objects. In this case, it's basically just shorthand for a whole bunch of other code. Okay, so when call start next level runs, then what it's doing is just saying, okay, I'm just going to start executing this dark blue block, whatever's there. Okay, and then what you had was you had to say, okay, change the current level by 1, and then say, all right, which level am I in? Am I in level 1? Am I in level 2? This could go on forever, conceivably. Um, and then set the game mode appropriately. Yeah.
So there's nothing explicitly coded here that resets current level to 0.
Not in start next level. However, okay, so that, yes, is actually kind of sloppy on their part. What we should do, oops, not that one. If we want to be really, if we want to be proper, that's what we should do, okay, is when the game starts, we should explicitly set the value of current level to, in this case, it would be 0, because what is the first level, or sorry, what happens, well, what is the first level called? It's when it's the number 1, right? So if we started at 0, and then when we call start next level, what's the very first thing it does? It adds 1 to the current level. So if we start at 0, then adding 1 to that would give us 1, which would start us on the first level. Okay, so yeah, go ahead.
So with Scratch, like, when you restart the game, does it like set all your variables?
Yeah. Okay. And so that's another thing that's hidden here is that, and I'm actually kind of surprised that it worked, because technically speaking, that's improper to not do that. Um, in so in some programming languages like C or Java, you can declare the existence of a variable without actually setting what its value is. Okay, so you can say, I'm going to make this variable a number, but not tell it what number it is yet. And then if you try to use that variable, but you haven't declared what value it has, it won't work, because there's no value there to work with, okay? Some other programming languages are a little bit softer in that sense, and what they would do is just say, okay, if you define the existence of a variable, but you don't tell me what its starting value is, I'll just pick a default value. And that default value in most cases is just 0, right? That makes sense for numerical stuff. Um, and so that's what the thing is doing here, is that we've technically defined a variable's existence, right, by means of having a change current level. So let me pull this actually out and put that back in, okay? And then what I want to do is I actually want to go over here to the Python view. Okay, so all of these things at the top where it says def, it's defining functions. Okay, so each one of those little blocks, like on a pressed or start next level or whatever, those are all functions. Okay, but then here, right, it says what kind of variables do we have? Global, current level, and my enemy. Okay, and then it's going to add current level. Now Python is nice enough that like you don't have to set the initial value of something. Okay, but technically we should set it to be 0. Okay, so all right, so where is the on game start? It'd be right there. Okay, so you notice that I never actually set the current level to be 0, because I pulled that little block of code out, but it is actually there in the Python code. It's just sort of hidden from us in block view. Okay, so it's like it's doing that basically so it doesn't make it crash. I'm actually surprised that it let us do that, because that's kind of sloppy programming. Yeah. Now with some other languages, and Unreal Engine actually would be an example of this, is that when you create an object that has, say, numeric variables attached to it, you can set what the default values of those variables are to anything of your choosing. And then it would be up to, either a teammate or you later to say, okay, if I want like to change the default value to, or change the value of something away from the default, that would be up to you. Okay, so a good example of this would be, um, let's say that you're making like a floor lamp. Okay, so the floor lamp, you have a mesh, which is the actual geometry of it, and then you have a light bulb thing on the inside that actually is going to cast the light. Okay, and you could say, all right, I'm going to make this object a floor lamp that has as its subcomponents the geometry, a collision box so that you can't run into it, and a light bulb, or maybe several light bulbs so that you can get the light looking nice. Well, you could say, okay, I want the default brightness to be some number. And then if I wanted to decorate this room and I put in like 16 of these different things, I could say, okay, I want this floor lamp. They all have default brightness of some number, but I can change this floor lamp's brightness separately from that floor lamp's brightness separately from whatever. Okay. Um, and so again, that's sort of this object-oriented thinking. But we would have to specify, and Unreal is going to be a lot more picky about these things because it's built on C++, which is picky about everything, um, to pay attention to the default values and declaring them if we make a variable. Okay. Okay. So does that kind of make sense? Yeah. All right. So let me go back to um, the block view just for now. So the other thing I wanted to talk briefly about was this dude over here, which is what happens if you touch an enemy, um, which is what happens when you touch an enemy. Yeah, exactly. It depends on how you touch the enemy or from what direction you touch them. So if you touch them from the sides or from the bottom, what happens? You lose a life and the enemy disappears. Okay. Now in like classic Mario, what would happen if you touched an enemy? One of two things. You would either die, or if you were big Mario, you would shrink back to little Mario. Okay. Um, and okay, so this is just a design decision to make it a little different. But point being, the direction or where you touch the enemy sprite changes the behavior, and that's what we've got here, right? So the sprite's bottom would be whatever the y value is of the bottom part of it. And if that's less than the y coordinate of the other sprite, okay, then that means that, or I'm sorry, I said that backwards because sprite is of kind player. If the player's bottom is less than the other sprite's y coordinate, that means I'm actually above the enemy, right? Because remember, the axes are backwards. Okay, and so that means that I'm touching the top of it. Now, strictly speaking, actually, what is the difference between the other sprite's Y and the other sprite's, um, let's see, where is that? I want, oh, I see. I just need to scroll a little bit. Okay. What's the difference between the Y and the bottom, or top for that matter? Yeah, the bottom of the graphics of the sprite. Okay. So those could be two different things. And in fact, the only situation that they'd be the same is if your sprite was just an empty thing, right? And there was no art to it. So if we go into the assets, and let me just pick one of these at random. Let me play the player asset. Okay. This 16 by 16 grid, right? So the position of it is basically where it's centered. Okay. But its bottom would be whatever the coordinate of the bottom part of the art is. And those are two different things, okay? Partly taking into account, well, this is a 16 by 16 thing, but it doesn't have to be a 16 by 16 thing, right? It could be whatever. Okay, so does that kind of make sense, the difference there? How could we apply this idea to this idea of being able to control kind of what direction we come at something? Well, let me just go into the game and play it for a moment. Okay, so classic Mario, right? I've got this exclamation block, right? What happens in some of the blocks in Mario when you hit them, particularly the ones that have the question mark in them? Yeah, something comes out of it, right? But only if you hit the block from the underside, right? If you jump on top of it, then nothing happens. It's just a regular block. Well, there we go. We have already figured out how to solve that problem. We would do basically like what we did for when the sprite or the player was overlapping the enemy, but we would just pick, the appropriate directions and sides and whatnot for whatever we wanted. Okay. This, by the way, let's take just in Mario the regular bricks that are laying around in various places. What happens if you try and jump up onto a brick or underneath a brick in Mario? Right. If you're small, it just kind of does the boo thing, right? But nothing actually happens. If you're big, then it breaks. Okay. Well, if we set a variable for the sprite or for the player that was basically its state, are you in small mode or big mode? Um, and maybe you could also have several other modes for like invincible mode, or you've got the fire flower mode or whatever. Um, uh, yeah, you could do that kind of detection. You could say, okay, if I'm touching the underside of a brick and I'm big, then tell the brick to break and do whatever. Otherwise, just do the little bump, and that's that, right? But we basically have solved that kind of question, right? It would just be an adaptation of what we've already done. Okay, does this kind of make sense? All right, so like what we did last time, you guys have all gotten this thing to basically this state. Okay, maybe you've tweaked a few things, or your art's a little different, or your numbers are a little different, but effectively we all have the same object right here. Okay, so what can we do to modify this? What kind of changes could we make? Oh, and I've been broadcasting the please wait thing all class. Whoops. Oh well. What kind of things could we modify? So let me just pop open a Word document here. All right, and let's do like we did last time. What kind of stuff could we add? Yeah. Environment. Okay. Okay. Yes, Ethan? Bingo. So that was one of the first things that I noticed when I was playing them, is that if you just spam the space bar, you could just fly to the end of the level, avoid all the problems, and then that was that, right? I mean, it's kind of like when you got Tanuki Suit in Mario 3, right? You can just see ya. Uh, well, yeah, but if you get a Game Genie, then yeah. Which actually, you know what would be kind of fun? Um, Maybe we've got a little bit of time left towards the end of class, particularly when you guys are working on projects and stuff. We can actually talk a little bit about how the heck the Game Genie actually worked. Oh goodness! Oh, this thing was the coolest thing ever. They don't have them anymore, so let's. Um, so it was this thing. Here we go. Okay, so you remember what the old school Nintendo cartridges would look like, right? All right, so you bought one of these things, okay, and you plugged your game cartridge into it, and it sat between the game cartridge and the the Nintendo, right? So it was basically, it was connected, but through this thing. Okay. And then what you did was when you fired it up, it basically hijacked the start of the game, and you could put in codes. Okay. And then these codes would alter properties of the game. So, for example, um, in the original Mario, the number of lives you have is stored at a specific location in memory, and it's the same for every physical cartridge of Mario in existence, right? Well, if you know where that spot is, then you can change its value or have the Game Genie basically maintain its value. So you could set it to be 99 or whatever, and then if you lost a life, the Game Genie would be like, nope, memory, I want you to be 99. And then you could have infinite lives. Um, and so then what came with it was like a book of different codes that you would enter that would tell the Game Genie what to do for specific memory addresses or whatever in various games. Okay. And of course, this was um, we didn't really have the internet back then, gentlemen. So you couldn't just like go and Google for the codes for it because Google didn't exist yet. And I mean, you kids these days have no idea the struggles. Yeah.
So would it change the values in the memory for like lives or whatever? It didn't like overwrite that permanently, did it?
Well, permanently in the sense that when the console was powered on, like it couldn't change anything. So, okay, good question. There are two types of memory that we talk about when it comes to, say, the old school Nintendo. There's the RAM memory, meaning it's values that you, or memory that you can change its values in, but if the system is powered down, that information is lost. Okay. Then there's also ROM values, which are things that are only readable. You can't write to them. They get written to in the factory, and that's that. So most of the game's data that's on the cartridge, right? If I'm holding a cartridge in my hand, there's no power. All the data there is in ROM data. Okay. But then something like the number of lives you have needs to be a changeable piece of information. And so while you're playing the game, that would be stored into RAM somewhere. Now, your default values for everything would be on the ROM when the game starts. Okay. And so, yeah, what it was doing was basically messing with the values in certain locations in RAM in memory. And all of these things had addresses, numerical addresses, and the ROM chunk and the RAM chunk, it was really obvious which chunk was which, but just based on their address number. It'd be kind of um, well, let's say in this building, right? There are room numbers. If I tell you the room 207, you know that it's upstairs. Okay. So if I said, okay, all the 100 level rooms are RAM and all the 200 and up level rooms are ROM, well, then it's obvious. You know that things in this level are changeable, but stuff upstairs isn't. Okay. Now there is one exception to that, which is certain games had memory on board the cartridge that could be changed, very small amounts of it. Okay, this would have been your like Final Fantasy or things like that where you could, or Zelda, where you could save your progress. Okay, but that also meant that they had to have a little battery on board to kind of keep the circuit active. Um, uh, One exception to that would be, you guys, did anybody ever play the original Mega Man?
No.
Huh? Okay, so in Mega Man, when you defeated a boss, you got a code that you could write down. And then if you put that code in to the game, when you powered it up, it would know, well, the code was basically unique to which order you went through the different enemies. Okay, so like let's say that you had gone through Fireman and Iceman in that order, then by the time you defeat Iceman, you've got a code that the game's program can decode to say, oh, he went through Fireman and Iceman, give him those power ups. And then you could sort of reset your game that way. But you had to write down the code and keep track of it, and it was annoying. And
Is that kind of like all those games where, like, if you go through it once, you go through it again, and something changed,
if it gave you a code or there was memory on board the ROM. Okay. Of course, nowadays, you guys don't buy games like this, right? Even your Nintendo, like Switch, the game thing, those are basically just SD cards. They can be changed. Now, the Nintendo Switch operating system is not just going to let you change them willy-nilly, okay? But I mean, this is how, for example, you can update a game that you've bought. Um, yeah. Now, does anybody actually get the cartridges for the Switch, or do you do direct download? You're a console or a cartridge guy,
well, the Switch only has like it has a very small amount of like
which is why you buy an SD card to put into it.
still.
Huh? Yeah, that's okay. Yeah, so this obviously, if you're direct downloading stuff, is a little different. Okay. Um, all right. So sorry, we got kind of off on a bit of a tangent there. Um, but yes, the jump, you could just spam the jump, and that's, well, kind of great for testing, but not so great if you wanted to deploy this as a commercial product, right? Okay. What else could we have changed or added or whatever?
Maybe you can add a power up that does let you do that, but like temporarily.
Okay. Yeah, definitely. Tanuki suit kind of thing. Now, in, of course, Mario 3, right, the Tanuki suit, you couldn't just fly anywhere you wanted, because what did you say earlier about it? Yeah, you had to run for a little bit and build up speed before you could take off, right? And once you hit the ground from flying, then you had to redo that, which in some